But with that, welcome to the the fifth FAA National Science Strategy Engagement Session. Last year, the FAA program managers tasked a small team to develop a new FAA National Science Strategy, which is informally known as the NSS. So the NSS is in its final draft stage before internal and external review. In today's session, we will have four 15-minute presentations, followed by a moderated 30-minute panel discussion by Dr. Sarah Goking. The themes of the NSS that are going to be discussed today are the importance of alignment, commitment to research, power of operations, and integration of research and operations. We will not be taking questions from the audience during the presentation unless time otherwise permits. Any questions regarding the NSS can be followed up with the team by emailing myself. And Gadana will put my email in the chat for those who are interested in sending out questions. Our first speaker today is Dr. Linda Heath, who serves as the R&D Washington Office Director of Inventory, Monitoring, and Assessment Research Branch. Linda, thank you so much for being here today. You now have the floor.
Okay, thank you, and good morning, everyone, and howdy. I'm just so proud to be here, and I'm glad that you're here to join us as well. Today, I have the pleasure of speaking about the value of a national science strategy. Larry, is that the full screen that's being occupied?
Yes, it looks good from my end.
Okay, all right. It's funny, I have two monitors, and what's on the other monitor is different. Okay, so a national so we're here to talk about the FIA National Science Strategy, but I can't emphasize enough that at the level of headquarters office, Washington office, and station leadership, it's important to talk about national science strategies for all the different research areas that we probably have enough investment in. And so I need you to think about like the big picture at this point for a national science strategy. We're here to talk about the forest inventory and trend analysis area that's listed in, well, let me back up to say the schematic here is a schematic of parts of the executive branch. And of course, we report up to the president, but our budgets, for example, come from Congress, the legislative branch. And what we do every year when you think about this, think about what you need to think about the Washington office, is that every year all agencies put together a congressional budget justification. And in there, we have we put in status of programs, what we're trying to do, what we have accomplished, what we're trying to accomplish this particular fiscal year, and then what we say we're going to do in a next fiscal year. In fact, right now we're working on a status of programs for FY26, and we're writing about FY25 as though we have clarity about what we're going to do in FY25, even when there's no clarity of budget. So we have this status of programs for research and development, and we describe research and development in 5 categories. Forest inventory and trend analysis is one of those. The other 4 are wildlife, there's climate, water, and then wood products and innovation. So just imagine and think about your day-to-day work and how you're thinking about all sorts of little details. But when we communicate out to the rest of the world, to Congress, who has the purse strings, to the executive branch, we talk about 5 general items. So we need to be able to collapse what we're doing and to communicate what we're doing in this high-level type way that people can grab onto and think about. So remember, that's the stance you need to be thinking about here, while simultaneously understanding that we need science strategies to also speak to scientists, to speak to all the other employees who are working on in the area that we're doing, in this case, forest inventory and analysis. Now, when I think about how science strategies help, one of the things I go to is down near the bottom, understand the research vision so that planning for execution can be clear and coherent, establishing guidance for integrating operations and research R&D at a national scale. I think, what a science strategy does, it helps us understand our vocabulary. Every time I go to these, I've been in new big projects, whether they be international or whether they be domestic, where everybody kind of has the same background. You still sit there and talk a while, and you realize that we don't have the same vocabulary, and we always thought I knew what that word was, and so it's important to have a vocabulary, have these standards, and come up with a framework really to clarify and articulate our shared goals and motivations, and helps increase this focus for employees and partners working together. The strategies also allow us to work with partners and bring them in early on so that they too understand what we're trying to think about and do there. Let's see, moving on to the next one here. Oop, how did I go back? All right. So why do we want to do this now? And why? Just to say, I'm drawn to ensuring the success of the program throughout future generations by enabling the proactive, coherent science planning, again, speaking with everyone, and trying to get not only scientists to understand what we're talking about for a strategy, but also in these nice little messages, very impactful messages that are clear, that we can deliver at these higher levels in Washington, D.C., to Congress, and with our partners who may not have the background we do on what we need, but they know what they want from us. So strategies are always important to do that. And in fact, I think about the 2016 science or strategic plan for FIA, and it has proven over the years to be really quite. It was just very well done, masterful. It's still current, even though it's 5 years out of date, so to speak. And as I said yesterday, I really appreciate what turns out to be not exactly a subtitle, but it's sort of a mindset on the front page of the FIA strategic plan, where it says collaboration or success through valued collaborative partnerships. And just that mindset really, I think, really sets the stage for the program, for all of us to know, what, we are going to collaborate. That's how we can be successful. And we value our partners, and we want you to feel valued. We want our employees, who are in a way our partners, to feel valued, because everybody needs to be at the table. We need help from everyone to bring their talents in and help us with just such a huge program to deliver our vision. Let's see here. Another important thing about a science strategy is promoting this alignment. It's the one on the bottom, the bullet on the bottom, among the 4 research stations in particular, because folks tend to have, everybody has priorities. So they're off trying to be successful, and we're trying to be successful. So how can we, the strategy helps us think about wording and framing the situation in order to be successful together. So overall, we have these objectives of the National Science Strategy, and so I think about the first bullet. We want to increase rigor, efficiency, and the impact of FIA through science. How do we advance FIA through the science that we're doing? I like the idea number 3 about establishing a framework. Strategic plans tend to be frameworks where we're looking to foster increased alignment among science practitioners and partners, where we're trying to, in this case, we've said our vision is to balance innovation with consistency. So that's another way in which FIA program is unique. Other R&D may be just looking at innovation, and we're actually trying to be doing something even harder. We're trying to balance innovation and consistency as it drives us along. And of course, we want to also drive along the collaboration of partnerships. I'd like to say one other thing about the FIA program that makes us different from research and development per se, and that is that we are a secondary statistical unit within the federal statistical system. And there are 13 primary statistical units in the US government. For example, Bureau of Census is one of them. And they look for direction from the chief statistician of the United States, who is in the Office of Management and Budget, which is an agency in the executive branch. And as a secondary statistical unit, FIA is, there's so much similarities when we're looking directly at the surveys. There's so many similarities when thinking about these other statistical units. And traditionally, statistics itself tends to be held a little differently from research, and you'll see this in the USDA Undersecretary area for Research, Education, and Economics, where the National Agricultural Statistical Survey, for example, is its own unit. This is not to say what the NAS does or a statistical unit does is not important. It's just the statistics and the surveys and the data production drive us towards a certain way, and not just all of innovation. So something to keep in mind as we do our work. Let's see. And to close here, just to talk about FI's vision. This vision is actually in the strategic plan that I mentioned about we want to be the trusted source of information on extent and condition of the forests of the US. But in the strategic plan, it goes further to say that the vision of FIA is to be the trusted data source of information where any decisions made concerning forests or the forest sector in the United States, and perhaps even internationally, depending on the decision, that every major decision is made with the use of FIA data or information or wisdom or expertise or knowledge. So, and it includes more than the extent and condition of forests. It's also the forest sector when we talk about National Wood Owner Survey, as well as the roundwood production and surveys, and even perhaps outside of forests in urban forests as well. So with that, I look forward to hearing the rest of the talks as well, and learning more and about this national science strategy too. Thank you all.
Thank you so much, Linda. Does anybody have any quick questions for Dr. Heath today? We have about a minute and a half before our next presentation. Okay. Well, then on that note, our second speaker today is Dr. Sharon Stanton, who serves as the Pacific Northwest Research Station FAA Program Manager and is also an NSS team member. So thank you so much for being here today, Sharon. You can go ahead and share your screen, and the floor is yours.
Thank you. So now that we understand the big why of why we've taken the time to put together this national science strategy, I'll share some highlights of what's actually in the strategy. It's important, as Linda alluded to, the context of FIA as a federal program with both research and production aspects. It does put us in a unique position that calls for a strategic and structured approach so that we can achieve that balance of both consistency and innovation. So I want to point out the team. This was a group effort. We tried to pull in somebody from each of the FIA units across the United States. So we have Mark Nelson, who's a research forester with the Northern Research Station, Kadana Randolph, who's a mathematical statistician with the Southern Research Station, Karen Schleweis, who's a techniques research team lead at the Rocky Mountain Research Station, myself from the Pacific Northwest Station, and Natalie Renkes, our fearless project manager. Thank you, Natalie. So some of the main components of the science strategy, we set it up in an arc that sort of gets at where we are today, where we want to go, and then some ideas and recommendations for how we could get there. The strategy also includes, as I just mentioned, a set of recommendations coming out of different aspects of the strategy. We've taken some time to establish important definitions. For example, what is science versus research? What is production versus operations? So there are some keywords that come up repeatedly in the strategy, and we did take a little bit of time to try to clarify some definitions so we all have a shared understanding. There's a section around communication standards for our science and evaluation standards. So how do we measure our success? How do we know if we are, in fact, achieving this goal of increasing rigor, efficiency, and impact? I'm going to walk through some of these parts and give a few highlights in terms of where we are. This is a reminder. It sets the scope around our founding legislation. What is the congressional mandate? What was some of the original intention as we understand it to be around those congressional mandates? What are our areas of expertise currently? What are some of the known impacts and contributions of the program? The key role of partnerships in our ability to deliver the program, and also an administrative and organizational overview. It's a large organization across 4 work units, actually 5, including the Washington office. There's slight differences across those work units. It's a lot of people, it's a lot of different ways of operating. So there is, I think, an element of establishing some of that background as we think about the future. Moving into the future, where do we want to go? This section establishes some guiding principles and values for our research decisions and direction. It reaffirms our commitment to the innovation cycle. This diagram in this slide is really simplified. These new ideas, these new concepts come out of research, come out of the science. Our goal is to implement those, test those, put them into the system in a way that we can assess and then refine, and then into the system to continue to assess and refine until we feel that they're sufficient in their development phase to be operationalized. We also highlight the critical role of partnerships, and this will come up frequently, but we cannot continue to, or we can never have been able to do everything with our own capacity in terms of just sheer workforce numbers, but also expertise, technological things that we are not able to do in-house. And so relying on these partnerships to help us get the work done, to help us take us in new directions is really critical. That's a part of where we are, where we have been, but it continues to be a part of where we want to go. This part of the science strategy also reaffirms our focus on research that improves the rigor, efficiency, and impact of the program. So those areas outlined in the Farm Bill already are the places where we continue to put the most emphasis and focus. We want a fully implemented nationwide forest inventory across all the 50 states, the US-affiliated Caribbean and Pacific Islands. We want to be able to continue delivering this efficiently, timely, with known certainty, unbiased estimates. So we're committed to conducting research that supports efficient, consistent, and rigorous NFI implementation. The National Resource Use Monitoring Program, part of the program also, completing an implementation and annualized reporting in all regions across the country to support delivery of a nationally consistent inventory. Also expanding partnership opportunities with timber industry, state forestry organizations, universities, and potentially some elements to add into the NRUM program, such as adding urban, non-timber forest products, or potentially like things like firewood. Also continuing to expand and grow the National Woodland Owner Survey, annualizing statewide surveys of the attitudes, behaviors, and characteristics of landowners, adding Caribbean and Pacific Islands where we can, so continuing to grow and expand that program continues to be a focus for FIA. Improving our reporting and estimates of biomass and carbon, advancing the science, monitoring, and reporting of greenhouse gas emissions, for example, continuing to improve spatial and temporal resolution of those carbon and biomass estimates, improving our estimates of fire emissions research and reporting is definitely something that's critical to us out here on the West Coast. Another key Farm Bill element is integrating remote sensing, spatial analysis techniques, and other new techniques in collaboration with other federal agencies. So again, this is to augment our plot data. It's not meant to replace the boots on the ground, but it's meant to leverage this vast plot network and the investment we've made there to get more information using these technologies. Also to enhance accuracy, precision, timeliness, effectiveness, and scalability over space and time of the plot network and the data that we have. Small area estimation is another strong area of emphasis that you will continue to see highlighted in the National Science Strategy. Modernizing methods for estimation of forest parameters within spatiotemporal domains that span substate geographies or shorter time intervals than our standard boots on the ground data analysis and inventory, looking at different subsets of the population, evaluating new sources of auxiliary information such as remotely sensed data that could be integrated. So this is a huge area of work that we continue to see high demand. Digital engagement is also an area where we're seeing increased demand and a lot of progress over time, but still work to do. The folks working on the digital engagement portfolio are seeking to radically reorient our analysis and reporting and knowledge delivery through application development that relies on off-the-shelf commercial solutions rather than in-house developed tools and applications so that, again, we can leverage existing investments. Land cover and land use change is an ongoing portfolio that we want to continue to emphasize, an ongoing priority for us. And this is to enhance and implement methods for consistent estimation of change through time. That's our bread and butter in FIA, is to be able to look at change through time, especially for non-forest use and cover variables, these things that are a little bit harder to get at from some existing other types of monitoring and inventory. So looking for ways to develop statistically advantageous, cost-effective uses of things like remote sensing or evolving model-assisted estimation techniques such as those we've been using in interior Alaska, although that is not a place where we're seeing a lot of land use change, but certainly land cover change. Annualizing the inventory of trees in urban settings is another area of emphasis for us. So continuing this nationwide implementation of an inventory of trees in urban settings, trees outside of forests, including assessments of ecosystem services, values, health benefits, all this other suite of information. And eventually the goal there is to be able to integrate this urban inventory with the non-urban forest inventory and really harmonize and no longer see the division between urban and rural information and have a seamless set of estimates and knowledge about the trees regardless of where they grow. Looking at how we could get there to continue to make progress on these priorities, this part of the science strategy really outlines some guiding principles for helping us turn strategy into action. Describes the role of management, for example, program management, but also project management, and highlights the need for an interface between research, development, and operations. Along with a clear alignment on FIA science priorities and initiatives, it's really critical to have an effective organizational structure and management to successfully turn this strategy into action. Strategic management requires that focus on these three, the research, development, and operations. And we'll hear a little bit more about that with Larry and Jim's talks today and how some of that, how we're exploring that and are making progress there and some potential for the future. Currently, the strategy outlines sort of 4 key levers, they're called, within the document of how these are things we can adjust to achieve our desired outcomes. So these are things around building architecture for knowledge management, improving our business processes, focusing on people and capacity, and strategic management of research portfolios, sort of sets of research. And I'll walk through these briefly one by one. So building this architecture for knowledge management. This is around centralized and transparent decision-making models and knowledge flows. So everybody understands where the decisions are being made, how they're being made, what information is coming into play there. Again, this formalizing of connections between research, development, and operations. How do we move through that innovation cycle? That innovation cycle, the more that we can all understand the parts of that cycle and where we can plug in and fit in, the smoother it will be for us to implement the ideas in this strategy. So this requires integrative management approaches. And there are, I mentioned, 4 different FIA units. Even within those units, There's different cultures. There are different ways of operating, different workflows, whether you're someone who focuses on the information management side of our work, or you're an analyst who's required to work with state partners and produce reports, or you're a research scientist who's working with the cutting edge of technology. There's slightly different cultures and behaviors there that we really need to integrate and bring together. And there are some architecture and sort of processes we can put in place to facilitate that. Another part of this is keeping up with technological advances and establishing a foundation for how we might be able to do that more effectively. I've already mentioned some things around business processes. We need processes that promote open information sharing and shared awareness and collaboration. Program management, again, how can we collectively prioritize, make decisions, and be transparent, and be clear about the criteria that went into those priorities and decisions. Change management, we have a really robust standard operating procedure for implementing change as we move something from research into that testing phase, into being operationalized. But it's still something that's a work in progress, and we're growing and improving all the time. We need to double down and invest in that fully as a program. Project management, I mentioned that Natalie's the project manager for the science strategy team. These folks are, and these principles are fundamental for us to figure out how to manage the resources we have available to us, manage our capacity, continue to meet timelines and deadlines, and make progress. So these are the sorts of business processes that the science strategy will help us determine the best way to implement and make progress for ourselves. Another aspect of how we could get there is that investment in people and the capacity and expertise those people bring. The team recommends a national assessment of current workforce and capacity. Some of this has been happening across parts of FIA. Within the research side of what we do, I think that there's still some space there where we could do a more fundamental workforce planning exercise. Related to that is developing some strategies for recruitment, understanding where our gaps exist and how we can bring people in, but also how we can retain the talent we currently have and find that balance between folks who've been here for a while and have a lot of institutional knowledge, but also bringing in some fresh ideas and some diversity as well. Clarifying roles and responsibilities, making sure everyone understands when they step into FIA, or even for those of us who've been here for a minute, what am I doing here? What role do I play in this innovation cycle, in implementing a strategy? And we've made a lot of progress there as a program over the last few years with some work across our units. And I think there's still more work to be done there that the strategy outlines a little bit. Partnerships and their role in building capacity. Partnerships is like the 10th time it's come up already, but that is a place where we can't continue to be everything for everyone. We couldn't and shouldn't have all the expertise in-house within FIA as a federal program. So let's leverage those relationships with external partners. And strategic portfolio management. For those of you within FIA, we have things we call portfolios. They're essentially those farm bill elements. We want to expand this idea. Really, the concept is stronger coordination across projects. That's the key thing. Stronger communication, stronger coordination, oversight of multiple research projects collectively, best practices, again, for decision making. How do we know when to start, continue, pivot, change, or potentially shelve a line of research? And some of these ideas are outlined in the National Science Strategy. So again, going back to Linda's comments about the grand vision is that we continue being the trusted source of information on the extent and condition of forests across the United States. And in a time of tight resources and sustained or increasing demands, in fact, on our expertise, on what we have to offer, it's really important that we can remain focused on the vision and our key goals. And for me, that's a big part of what the science strategy will deliver. It'll help us have a shared understanding of what the future looks like so that we can retain our focus on the future and help us not get caught up in the day-to-day distractions. It'll improve our ability to support scientists, to support our user community, and to support our partners. I mean, that's the goal of the science strategy, that we can continue being the trusted source. And I liked someone put in the comment about doing the right science, not just more science. And for me, that's what the science strategy is all about. It's very close to being final. We have a nice draft. There's all the parts are there. It's in that revision phase with 4 authors, really 5, because Natalie's weighing in now too. We're in those phases of finalizing and cleaning up, and we'll be seeking some review from folks outside our small team in the near future. So I think with that, I am ready to pass it on to our next speaker.
Thank you so much, Sharon. Appreciate it. All right, so our third speaker today is Dr. Jim Westfall, who serves as a research forester with the FAA Northern Research Station. So thank you so much for being here today, Jim. You have the floor.
So thank you. Today I'm going to talk about integrating research and operations, and specifically in the context of the National Scale Volume and Biomass Project. To avoid saying that over and over again, I'm going to refer to it as NSBB in the future slides. So I kind of view this project as FIA being responsive to stakeholders. And a little bit of background is that around 2009, FIA implemented what was called the component ratio method for predicting tree biomass and carbon. And an advantage of this was that it really increased the national consistency in how we did it and the components that we reported on. But at the same time, there were some pretty large differences between the component ratio method and the regional methods that were in place previously. So due to those concerns by some partners about those large differences, the NSBB project began. The initial meeting was, I believe, October 2011, and there were a number of participants in that meeting representing the Forest Service and FIA, particularly forest industry and academia. And basically, the goal of the project was to either validate the component ratio method, that it gave accurate biomass and carbon predictions, or develop new models if necessary. So this is my big partnership slide. Getting this project underway, keeping it going, and getting it across the finish line took the help of and dedication of a lot of people. Ultimately, we worked with 7 different universities that you can see there. And what may not be quite apparent, but you can see that they're pretty well spread out across the country geographically, which was purposeful on our part. A lot of industry input from Cassie, Rainier, Potlatch, and Weyerhaeuser. Other Forest Service contributions outside of FIA, like the Forest Management Service Center in Fort Collins, and also from various National Forest System regional staff. And lastly, I of course would be remiss to not recognize the FIA contributions through the 4 regional units and the Washington office as well. So there were quite a few people involved in this project to conduct it nationally. So if we were going to try to validate the component ratio method or develop new models, one thing that we really lacked was data. And so one arm of that was to do felled tree samples to fill in data gaps. And so, we may not have much information on certain species. A lot of biomass studies don't really have many large trees in those data. So there's a tree size gap. And then just, geography as well, right? Just spatial coverage. And into this project, right, from a national perspective. One thing we realized early on was that it takes a lot of time and money to do felled tree samples. So we really needed to bring in other data. We call this the legacy data. It was basically existing data from existing studies, some done by the Forest Service. Some of it could be found in master species or PhD dissertations and elsewhere. But basically an effort to just get as much existing data as we could find. And of course, that helps us increase our sample sizes, which we fairly desperately needed. And also helps with that coverage of the range of species, tree size, and geography that we're trying to attain. We also got some other, what I call non-public data, and these were data that were given to us from various industry studies, and also access to the N4 data set, which is a Canadian data set on tree biomass and paper. So how did we structure this? Well, basically through the universities, we had research agreements, and that was primarily focused on the felled tree work and also the legacy data collection. And we did get some guidance, right, from the FIA plot data itself. It's like, what's the range of species out there and their geographic occurrence? What are the ranges of tree sizes that we see in the FIA plot data? And then also, right, spatial distributions, for a given species, what's its range of occurrence? There was a good publication that came out of that Jeremy Frank and others put together that basically was the results of that study that showed, where were the data gaps that we were needing to fill in. Then, in addition to the university agreements, we also had in-kind cooperation from forest industry and U.S. Forest Service National Forest System. And this took the form of, technical expertise, getting more legacy data, and access to land to do some of the felled tree work. So process-wise, how did this work out? Well, we basically did monthly conference calls. This was mostly just for participants to provide updates, coordinate efforts in cases of, where it may make sense to do so. Then there was also like the problem solving and efficiency aspect of it, right? Like someone might run into something in the field they hadn't encountered and, could bring it back to this group and say, I ran into this, how do you think we should deal with it, kind of thing. We also had in-person meetings several years apart, and that was more focused on big picture collaboration items. I grabbed something from one of the notes of one of those meetings, right? And this is like, are we all on the same page about where we're going here, right? We want tree level models to give consistent transition across tree sizes and geography and species. We want our total above ground biomass to have additive components. We want to be able to quantify the tree level model accuracy and error. Of course, it all has to be transparent and documented. And for FIA to use it, right, it has to be backwards compatible for our database. So those are just like some of the big picture things that we would talk about in these in-person meetings to make sure we're all heading in the right direction. So we have this legacy data that we're working on and the felled tree data. We needed a place to put it, right? So a national database was established. There are various tables by data type, somewhat similar to FIA-DB, right? Like, a table with stem information, a table with branch information, and so forth. There was also consistency, right, in naming conventions and definitions. And with that database comes a data dictionary. So if you look in that data and there's a variable and you're not sure what it means, you can look it up and see how it's defined. Part of this was also the paper to electronic conversion. That was mostly legacy data, but there was a fair amount of work involved in that for the stuff that was on paper to make it electronic and put it into this national database. And these data are publicly available. You can see through that link there. So not only was it an important thing for this study, but it's also now available essentially globally to anybody who wants to access that data. So eventually we moved on to the modeling phase. Of course, FIA wanted compatible volume, biomass, and carbon estimates, but there's many ways that you could approach that to make it happen. And so we came up with this scorecard approach, which essentially allows us to assess the bias and uncertainty of various modeling approaches by looking at R squared, mean squared error, and things like that. And you can see there's just a short, I did a short, small screen grab there to see some of these statistics that we were populating in those. So that allowed us to do some comparisons across different approaches. And of course, we want to have this sensible allometric relationships, right? We expect these models to show those and not do funny things unexpectedly. And then, right, as I mentioned before, we have to consider FIA operational feasibility as well in the final product. So eventually, after various reviews by FIA representatives and other people, we chose the models that were developed at Virginia Tech. And so, you know, the fairly big lift at this point is now to do the implementation piece, right? And so there was a tech transfer activity between Virginia Tech and FIA, you know, basically like, you know, what is this system? What does it even look like? You know, right? FIA needs to understand it. Then FIA needs to code it. So that took a fair amount of work. Once that was done, right, there's the testing phase. Does the code FIA wrote actually give you the right outputs? Having done all that, right now there's the next piece of it is all the tools have to be updated, like eValidator and Datum. The user guide has to be updated to reflect all the new variables. And then internally, right, we did some population estimate reviews, mostly through our information management and analysis band staff just to give them kind of a look and go, you know, is there anything funny that stands out, or does it look like, you know, we're in pretty good shape before we release this to the public. Then the other part of implementation was the communication piece, right? We need to get this out to all the FIA data users. So there was a web page devoted to the project. It was mentioned in the R&D National newsletter and other Forest Service media. A lot of outreach to federal, state, and other partners through internal and external webinars and other types of communications. Then lastly, of course, the GTR that describes all the details of how it all works. So looking back on the project, like to me, one of the keys was just like ongoing communication, right? Like one was just internally, right? Keeping our program managers in Washington office up to date on what's going on, keeping techniques, research people, and analysis staff in the loop on where we're at. We had NSVB sessions for many years at the FIA Symposium to let people know what the latest happenings were. And then I think since like 2014, we had annual presentations at the FIA National Management Team meeting. So anyway, just a lot of ongoing communication internally and externally, I think helped keep the project going and ultimately get it into operational use. And then just to finish up, the FIA contacts regionally were myself, John Colston, John Shaw, and Andy Gray. And if anyone wants to, feels like they need to talk to somebody in the Washington office about this or not, that would be the current person to communicate with on that. And that's all I've got, Natalie, so I'll hand it back to you.
Thanks so much, Jim. There is one question in the chat. I think we have about a minute if you'd like to answer it either verbally or via the chat.
Let's see
Jim.
here. Yeah, so Shad, I am not sure about the timber sales. I know that, for example, it has been programmed for FVS users, so it's an option you can select it in FVS. But I'm not sure if NFS itself is using it for timber sales, and maybe someone else on the call might know more about that. Renata looks like she knows about it.
Yeah, I was just going to say that for adaptation by National Forest Systems, it will take a while. I know that some regions and forests are looking into adopting the national scale volume biomass equations and using them in their geographic areas. However, some forests and regions have more site-specific volume equations that have been developed over time that they're not so, I guess I'm thinking about timber cruising and stuff. So they're maintaining the systems that they have in place, and it takes just a little bit of time to transition over. So they'll need to test. The other thing I want to clarify, Jim, is, and Chad helped me out here, the national scale volume biomass equations actually are not yet available within the forest vegetation simulator. So that also is a little bit of a wrinkle for adaptation by National Forest Systems, because all of their current volume equations that are used for cruising timber are within FVS at this time.
Thank you, Renata. Okay, well, we have to move on to the next presentation. So our final speaker in the presentation portion of the NSS session is Larry Weigand, who serves as the Research Information Management Coordinator for R&D Washington Office, IMAR, and recently finished a detail with the Cross-Agency and Cross-Deputy Wildland Fire Management Research Development and Application Program. So Larry, thank you so much for being here today. You now have the floor.
All right, thank you very much. So I'm going to talk a little bit about a new framework that's being developed. It's been in development for about a year now. Research to operations, and it's actually research to operations to research, but that's too many words for this particular slide. So we'll focus on R2O, research to operations. This originally came to life for fire applications, fire management applications. But we took a look at it very early on and said the scope of this needs to be expanded, and we need to take into consideration as we develop this framework what's already being done across the agency. And FIA already has this research to operations down pat. So we took a look at what FIA is doing right and what needs to be done for other applications across R&D, and this is where the framework was born. All right, so there's three main blocks to this, and then you'll see this theme throughout some of the other slides as well. So R&D is on the left, operations is on the right, and there's a transition period in the middle. Worth highlighting here is the partnerships. We talked a lot about partnerships. The operational environment may not always be a Forest Service CIO environment. It might be another federal partner like Department of Interior, or it might be some non-government organization that we partner with. So just know that operations isn't synonymous with Forest Service CIO. It could be anywhere. At the core of the framework are readiness levels. We have technology readiness levels and human readiness levels. Those complement each other. And there's a new readiness level scale called AIRL, Artificial Intelligence Readiness Level, that we're looking at as well. It doesn't necessarily apply to this presentation so much, but AI is not going away. We're going to start using it more and more across the agency, and it really requires its own scale because it's fundamentally different to implement an AI system than other systems that are just perhaps server-based or cloud-based applications. So technology readiness level, let's talk about what that actually is. A TRL, it evaluates, tracks, and communicates the operational maturity of a particular technology or a system. Basically, will it function as it's intended? Human readiness level, again, complementing technology readiness level, evaluates, tracks, and communicates whether the technology or system is ready for human use. Will the people use it as it's intended? That's really the question to ask. When you're assigning a scale, one of these scales to a particular application, let's just say, for example, you have an application that's fully baked and it's operational on TRL 6. You want to make sure that the HRL, or human readiness level, is no more than one level behind the TRL. If it is, if you're stuck in HRL, for example, 3 or 4, and your technology is in TRL 6, you really have to stop and ask yourself why. What is it about the tech transfer or the human side of it that isn't up to the same scale as the application of the technology itself? So it's really important that those stay aligned as you develop your application and move it into an operational world. All right. This is what it looks like on a technology readiness level and the definitions for each of the levels. Interestingly enough, when we started looking at this framework, we started looking at other government agencies. Are we the only agency trying to solve this problem of getting an application from research into operation? And the answer is a resounding no. There are many other research organizations that are struggling with the same concept and process. This is where TRLs, technology readiness levels, came from, as well as HRLs. If you go out there and Google research to operations, you're going to see, in many cases, a scale that has 9 levels, not 6 like we have here. We just happen to have, within the Forest Service, we just happen to condense 4 of those levels into the transition period that you see in the middle. So individually, yes, they add up to be 9 different sections here, which jives just along with the normal TRL use across the government. We just happen to have 6 of them called out here. Highlighting governance on this particular slide. Bottom line is when you move an application from a development world into some sort of an operational world, you're going to need some level of approval along the way. It might be multiple levels of approval. What's called out in that block at the bottom there, the different acronyms are just different governance boards and organizations and processes that you might have to go through. But again, the thing here is all along the way through TRL 2 all the way into 4, at the end of 4, and as you transition into operation to the TRL 5, you are going to be checking governance boxes along the way. And if you don't check those governance boxes, you probably aren't going to advance your application or your system to the next level. But you still might have a useful tool. That useful tool might need to still get out to the public in some form. How do you do that if it doesn't get operationalized within the agency or with a partner? There's a couple of alternate paths here. One would be, and this happens a lot today, we have a lot of research applications that are developed that these tools get posted onto an R&D website, and they're available for anybody to download or to use. Or they accompany a publication when the results are published. Sometimes the application is made available for download as well. For those ideas and those systems that don't have an alternate path and cannot make it into operations, well, that's a good idea that goes to die in the valley of death. That's where they end up. It's basically a graveyard of all of those good ideas that didn't have an institutional or operational path in mind. One note of caution here, and we see this quite a bit today with a lot of R&D tools. Users don't necessarily differentiate between available and operational. They often assume that because it is available to them to download or to use from a website, it is an operational tool. And that just may not be the case. The science may be continuing on that particular application, and it's evolving and it's changing, and the application might have significant changes made to it. And all of a sudden, on a Tuesday, somebody comes into work and there's a brand new version of this application on a website. And unfortunately, it might break some internal process that organization might have been using that tool institutionally. So it's really important to make sure that your users understand that this particular tool may be changing over time or will change over time. It's important to make that very, very clear. That way they don't run into a broken application or a broken process. Human readiness levels. This is what HRL looked like. Human readiness levels is basically tech transfer and training and making sure that the users are going to use the system as it was intended and they know how to use it. It's really even more critical to make sure that they aren't using the system in inappropriate ways, because for example, there are some tools that are out there that aren't very intuitive to use. You need to have some level of understanding. So if you are using it improperly, it may not work like it's expected, and they think the application is broken and there's something wrong with it, when in fact it works fine. They just don't know how to use the application properly. So making sure that training is available, documentation is available, version control is available, that sort of thing is really, really critical. And again, HRL should align with TRLs. AIRL, worth noting on this particular slide or highlighting are the 2 black arrows at the top. When you develop artificial intelligence, you're really starting on the far left side and at level 1. When you're purchasing artificial intelligence solutions, you're skipping the development side and you're typically going straight into some sort of a transitional or operational deployment. So you jump straight into level 4 when you're purchasing. And the verbiage on each one of those levels is completely different because you've got to focus a lot of attention on your data when it comes to artificial intelligence. We won't talk about that too much here. This particular slide, the IT folks, the information technology folks tend to really like to nerd out on. But basically what we're talking about here is research to operations. And that transition period that's in the middle, it's really, you could be going from research to development to field testing to QA or quality assurance to final testing or into training. So you could be going into multiple environments that were stood up to transition into operations, but those environments were stood up by the operational team. So you might have 4 or 5 different iterations of a transition period until you finally get into operations. And it's really important to note that each one of these particular transitions for each application may look very different. It all depends on the application. It really depends on what's required of that application. Not all applications go through user acceptance testing, the UAT. Some do. Computer systems, you might start off in the lab or at a university partner, for example, and all of a sudden you're developing and testing into a true development, a dev environment or a test environment that's prepared just like your operational environment is. And then you move into the operational data center or into a cloud system. And of course, in the cybersecurity end of things, you need to have an authority to operate or authorization to operate. That's the ATO, that's the cyber world. On the left, you've got minimal controls. You want to have some freedom to develop that application, make some system calls at the operating system level. And on the right side in operations, you have virtually no access to those things. You are a user only at that point. So there's maximum security controls in place on the systems, and that protects your data and it protects the application itself. What does a transition look like? Well, it could change from application to application, but this is a good example of what it would look like. Transition team is established, feasibility assessment, plan and schedule, test and refine, finalize and release, and then continuous research and improvement. Again, it looks like a checklist in each one of these sections, and it probably will turn out to be mostly a checklist for each one of these phases. Final slide. It's important to note that while this looks like it's a very linear process, it's not. This is intended to be continuous research, integration, and delivery. So there's a constant loop going on here. So you might have an application. FIA's applications are solid. They're baked. They're probably all in TRL6 and HRL6, but the next iteration of them is back in TRL and HRL3 or 2. So it's constantly changing, and eventually that TRL3 iteration will make its way to replace the one that's in TRL6, but it will come right back around in a cycle and do it all again. And that is it for my presentation.
Thank you so much, Larry. Appreciate you being here today.
Yeah,
Does anybody have any questions for Larry? We only have about a minute here.
I'll jump in with a question.
Yeah, go ahead.
So Larry,
Is this the kind of structure that we should aspire? One of these structures, something we should aspire, we FIA to manage these kind of systems with?
Yeah, and it's really across all of R&D, and we're trying to get buy-in at the CIO level where the CIO should adopt this framework as well to aspire that all applications that they deal with use this framework in these types of scales. Yes, it's really across the board, and we've actually taken this framework that you just saw, and we've zoomed that out a little bit so that this particular presentation and framework is research to operations. But the reality is this framework can apply to a much larger scale. So the framework has been zoomed out, and it's now called idea to operation. So it's not necessarily an application that's developed in R&D. It could be an application or a system that's thought about by anybody in the agency and then ultimately needs to make its way into an operational environment. So idea to operations is the big picture. Research to operations is a little bit more fine-grained. And then AI to operations is also as fine-grained as research to operations. So yeah, I think every application and every system could fit this.
to help with
management or the development management of it and reporting of it as to what stage the activity is in.
And its usability. I mean, and it's really important that HRLs align with TRLs to make sure that your end users are getting what they need and getting what they're expecting. So, you know,
so you probably would have technology and the human one. You'd want to have both of those on a.
yes, absolutely. Absolutely. And then when you're looking at an artificial intelligence application or system, you would have AI RL and human readiness levels together, those two scales. And that's what you're measuring. You're probably going to drop technology readiness level when you are looking at an AI application. AI is very specific, but when you're talking about just normal applications, web-based or server-based applications, TRL and HRL go together.
Okay,
All
thank
right,
you
I'm
so
gonna have
much.
to, yeah, thank you. I'm gonna have to interrupt. Sorry, guys. Thank you. This completes the presentation portion of the session. And we will now proceed to the panel discussion portion of the session, which is comprised of 4 presenters and moderated by Dr. Sarah Goking, who serves as the Forest Inventory and Analysis National Program Manager in the R&D IMAR Washington office. Again, we will not be taking questions from the audience during the panel discussion. Any questions regarding the NSS effort, you can follow up with me. So thank you so much. And thank you everyone who presented today. Sarah, I'll pass it off to you.
Thank you, Natalie. Thank all of you for those great presentations. And thank you to those of you in the audience for being here. We have a list of what I think are some pretty interesting questions following some good overview presentations, different aspects of science in FIA. So panelists, for each question, I'm going to ask you to self-nominate to answer any particular question. I might target a couple of you for specific questions. And you can, but are not required to answer every question. So to start, this is one of those questions. It's more of a comment to start. This session was set up to combine 4 perspectives. First, the Washington office IMAR perspective, highlights of what's coming in the National Science Strategy, an example of FIA research partnerships and knowledge delivery through operations via the NSVB, and then exploring the interfaces of research, development, and operations. So after listening to each other's talks, is there an intersection of perspectives that connects or separates these topics that you think deserves to be highlighted? The floor is open to the panelists.
Okay, I'll self-nominate.
Thank you.
Yeah, I took a note during the other presentations, and I'm glad it was repeated in really all the presentations. But do the right science, not just more science, and that's really important. And I would actually add to that and make it available for use. So I would extend that a little bit, but I think that's the intersection amongst all these presentations and really the glue that holds it together, in my opinion.
It's a great synthetic comment. Thank you. Any others?
I'll jump in. Well, I guess this was my typical story, is that when I think about all of this, I think it really comes down to that mindset that we have about success built on valued collaborative partnerships. I mean, all of this takes working together and communicating and just being this is what, we all seemed dedicated to doing what the end goal is, and we've bought into the end goal, and we're bringing our talents together to do that. And so I think that mindset really resonates with how much we want to kind of learn and do what we're doing here, because in general, we're trying to be really efficient to fulfill our goals while our goal expands. And I think besides the fact that inventories are efficient, and need efficiency, I also think that we tend to have that mindset, that we tend to be passionate about actually what we do, and we want to see the program be successful. So I'll just leave it at that. Thank you.
Thank you, Linda. Okay, I'm going to move on to another question then. Thinking about doing the right science, which Larry reiterated there. I'm first going to target this to Jim and Larry, but Sharon and Linda, you can chime in too if you want. What advice would you give scientists to ensure that their work is well oriented within the research to development to operations framework and the science strategy?
Jim, you want to go first, or you want me to say my piece?
Yeah, go ahead, Larry, and then I'll follow up.
Yeah, I think probably the most important thing, and by the way, we haven't fully implemented the framework that I just talked about yet, but I think the most important piece to this is communication between the researcher and the operational environment in which it's going to land. It's really, really important to start that communication early and keep it going often. There is too much opportunity to develop a tool or a system in a silo, and then it won't fit into an operational world. And then it's forced down an alternate path, and it may ultimately die because it couldn't be operationalized. And that's a bad thing when you have a good idea that can't move anywhere. So communicate well and communicate often. Jim, turn it to you.
Yeah, thanks, Larry. Yeah, I think the other piece of it, right, is, it's kind of been hinted at already, right? This do the right science kind of thing. Right, well, I've been under the opinion for a long time that, right, there are a lot of pretty smart people in FIA and elsewhere that we collaborate with. There's a lot of desire to move the program forward, and so we basically have the ability to generate way more research than we can operationalize, right? And so then it comes down to like prioritizing, like what's important to the program. And so I think for scientists, right, to be working on the right science is to, be engaged, right, with your supervisor, your program manager, pay attention to, what's coming out of regional and national user groups and things like that. Because those are probably going to, indicate the types of things that are going to be important and rise to the top and get operational resources devoted to them. Whereas, other things that maybe don't fit that bill, right? You can do the research, but the operational piece is a challenge just due to the amount of work we have to do overall with limited staffing.
Thank you both. And as a follow-up bonus question, does anyone want to draw any linkages between the answers we just heard about prioritizing the right science and operationalizing it, and what's anything currently going on in FIA?
I can speak to that.
Thank you.
So I mentioned in my talk around the need for processes and transparency and decision-making and prioritization. And I also noted some cultural differences across different parts of the program. And there's been a tremendous amount of work over the last 2 years, really, for us to identify some of those barriers for us to work more consistently nationally in particular. And one of the key things that's come up is how do we prioritize, right? The big picture research things really come from our partners and user community in the Farm Bill. But the devil's in the detail about, okay, now we have a piece of small area estimation. How do we move that forward programmatically through that cycle of innovation, through everything Larry just talked about? And we do have a prioritization process that a team of folks has been developing over the last year. And we're kind of putting in tests this year right now. At this moment, we have a meeting in 2 weeks where we will come together across all the FIA units and look at how that process worked. Are there some new things we want to add? And so again, back to that idea of putting some best practices in place and some criteria and guidance. And it gets back to Larry's point about communication, making sure everyone understands how they can avoid working in a silo, because I don't think that's intentional. I think that's largely just a practicality of how we work. And so making sure people understand how they can get out of their silo, how they can communicate early and communicate effectively, because you may think you communicated only to find out that the message didn't get through. So we're really putting some processes in place and guidance to support that across the program.
Great. Thanks for that update on what's going on in the program. Yes, Linda, you look like you wanted to speak to this as well.
Well, what I'd like to speak to is a little different because, and I would like to say when it comes to how the question about how to have scientists make sure scientists ensure their work is well oriented within the framework. What I would like to say is tell to sell. This is a head of previous station director who would always say tell to sell, because sometimes it's really hard sometimes to know what the right science is. And the scientists may have a great idea, and it may have application in a way that we can't understand it automatically. And so if scientists could tell to sell, to kind of talk about, yes, but this, and could say it in a way that we we listen in a way that we might find out that oh, what a great idea. So it's not just I have probably more of a research background outside of FIAs. So sometimes those kind of strange kind of ideas can really come in and really help your operations. So that's what I kind of tell to sell. It's really important for all of us, including scientists, to continue to get your message honed and tell to sell. That's what I like to say. Thanks, sir.
Thank you, Linda. So I'm going to direct this next question to Sharon and Linda initially, and Larry and Jim, if you want to chime in, you're welcome to. But this is actually sparked from a question early on in the chat. How does or how will this science strategy interface with the FIA strategic plan and FIA's mandates that come from the Farm Bill?
Yeah, I can start with that. The strategic plan I think of as it's a much bigger plan that sets up our overall direction, our vision, our goals for the entire program, not just the research aspects, but administration, operations, data delivery. So it's a plan and includes a fair amount of detail around implementation. It outlines what resources, specifically what funding would be needed to implement different Farm Bill elements, for example. The science strategy is more specific to the research projects and integrating those research projects into portfolios of work and getting them into this cycle of innovation to move through the process of development and operationalization. For example, delivering 5-year reports, that's clearly a program strategy, but it's not necessarily a research priority, or I'm sorry, the 5-year reports is a program priority, but not a research priority. So looking for a little bit of that distinction that allows us to, again, set up some guidelines and facilitate the success of that innovation and research side of things with some sideboards to allow us to continue to implement the strategic plan. So the research strategy could almost be a subset of the upcoming revised strategic plan. So that's my take on it. Linda may, again, have a slightly different take, which I'd be interested to hear.
Well, I would agree with what you just said about a subset or contribute to the hopefully upcoming new strategic plan when we get to one. From my point of view, having a plan like this is really helpful because it gets back to the tell to sell and the communication that there's main messages in there, and this is how we can help, especially help work across stations and get buy-in from R&D leadership, and also hopefully recognition from the agency at large, because what happens is, especially when you think about farm bills and things that was mentioned, we do help at the Washington office level contribute text or review text that is in legislation. In fact, we had to do something really quickly yesterday on reviewing some text and giving technical assistance, for example. But we do review farm bills as well. So anyway, having this agreed upon plan, or it's a start. Everything's sort of a start. We'll have this, we'll talk about it, we'll learn from it, and modify that as we go. So I see it as really helping at the larger level, at the higher level, trying to get our messages across well, and of course try to get more funding is what we really try to do where we're at. So that's what I'd like to say. Thank you.
Thank you. Larry or Jim, do you have anything to add to that? Okay, thanks. I'll move on to the next question then. You often hear about leadership, and leading people through change. And we've seen a lot of change. We're probably going to see a lot of change. So if you think about some of the biggest changes you've experienced, say in the last 5 years, and changes that you expect to see in the near future as this plan is finalized and then implemented, how do you think changes and the current environment will affect how R&D or partnerships will be conducted in the future?
Go ahead and offer a little bit here. So I'm going to come at this from a technology perspective, since that's my wheelhouse. So I think over the last 5 years, R&D has been able to take advantage of performance computing options that they perhaps might not have had at their fingertips before. I think previously, if somebody was looking for supercomputing time or high performance computing cluster time, they would be looking at a university partner for that technology. Now it's more available to them just by coming, to the resources within the Forest Service. So I think in some respects it might reduce our dependency on partners for technology, computing technology, but it won't eliminate it, because let's face it, I mean, the universities just have they can afford much better computing technology than we can in the government. So even if we had a huge budget, which we don't, but even if we had a good budget, we would still be struggling with our technology delivery. So I think just over time, just having access to performance computing and cloud technology and AI becoming more prevalent. I mean, let's face it, AI has been around for a very, very long time. It's just now a thing, and I think it's just going to improve our relationships with our partners.
I'll just jump in and say, when I think about this strategic plan and change now versus, say, 5 years ago, everything does seem to be very faster, dynamic. There's all this change going on. And so I think having a strategic plan like this one will help provide some stability or that we can turn to say, okay, this is sort of the framework, this is the language we're using, this is our expectations, and will help keep help with the change management, being that we can live more with this change management as we rush along in it, as how I look at that. That's one thing I really like about strategic plans, is it kind of gives you it gives you an anchor to hold on to as all this change is going on and all these great new things like AI come along, but yet we can still hold to that anchor. And eventually, that's why, of course, we have to update our anchor as the change becomes so great over time. Thank you.
Yeah, I would add to that. Some of the big change I have seen, I would say 5 to 10 years ago, a lot of our partnerships felt more local or regional specific. And there's been this real shift towards more emphasis on larger geographies, larger scales, larger time scales, bigger kind of overarching issues and questions people want us to address. And some of that could be related to these technological changes that Larry kind of alluded to, that it's a more of a global world. We have different ways of communicating. We have different technology. I think we've adapted well, but I do see that that's a place in the next 5 years. We're going to continue to see that shift into bigger scale and being more national in how we operate, not just internally, but I think externally with our partners and collaborators and user communities. They just sort of want things at bigger scales. And I think we're in a good situation to be poised to deliver that.
Yeah, Jim.
Yeah, I guess I'll just chime in quickly, Sarah. I agree with what Larry said, right? We have access to a lot better computing resources than we used to have. But then, kind of building on what Sharon was saying, right, with these more nationally aligned type of work, we have we still have this need, right, for flexibility, I guess maybe is the term, right? And so like one example, like with NSVB, right, was this data national database that every participant could hit off of, so we were all using the same data. And maybe George can comment on this at some point, but like what I've seen with SAE, right, is right, there's a lot of university players and other folks, and they kind of need like a playground to test in where they can go in and write code and do all sorts of things. And I don't know if we're fully there yet on the Forest Service side to be letting a bunch of people come in and start writing code that gets submitted to our systems from a security perspective. And so I think that's another advantage of these partnerships is that we still have kind of this need for universities to maybe host some things that may allow a little more flexibility than the Forest Service systems can provide.
Thank you. Those were 4 great and very different insights. Very much appreciate that. I'm going to try now to get through 3 questions that the team came up with short answers. The last one I'm gonna hold and make sure we get to the very last one. But first, what is one thing that you think is required for FIA as a research organization to reorient for improved research and operational outcomes under the science strategy? Reorient can mean a lot of things.
I'll go ahead and start with this one, and I'm going to tag on to what Jim just said about the playground environment. The playground environment, because you're looking for flexibility, often means that data is copied. And in my opinion, FIA could benefit highly from having a true playground, a true development or a pre-development area, if you want to call it that, where data is not constantly being copied. Stop making copies of data. That would be my offering.
I'll jump in and say, practically speaking, anytime we do something like this, having project managers available to help implement is really always key.
I'm going to say a science strategy. Need a science strategy and need to follow that strategy.
I'm supposed to be objective, but I'm going to say good answer.
One thing I also see, Sarah, too, and it is part of all these national issues that we work on, right? Being in a more formalized, structured environment, I think we also tend to get better participation, right, across FIA, right, which helps obviously, in the end to make sure that solutions that all 4 regions can live with are put forward and things like that. Whereas before, when it was less formalized, right, where it was more like a, who wants to raise their hand kind of approach, or just who do you know kind of approach, then sometimes, right, maybe some perspectives might have been left out.
Yeah, so in inclusivity, communication, again, it sounds like across units as well. Okay, this question, we don't have a lot of time left, but I really want to know. I have 2 more short ones, so only answer if you really want to on this one, and the next one I'm going to ask you all to answer. But how do you inspire others while keeping yourself inspired about the Forest Service R&D and the FIA mission? I really hope you have answers, because I get hope when other people have hope.
I can jump in. I'm not sure I do effectively inspire others, but I aspire to inspire. guess Maya, each person's unique. What motivates or inspires you may not be the same for me. And so I really try to listen and really listen to learn and understand where people are coming from and meet them where they are, find out what works for them. And I think another thing is staying focused on the big goals, the big why. Again, what we do is really complex. It's busy. There's a lot of things we're trying, a lot of plates we're spinning, as some would say. So really staying focused on why we do what we do and why people care about what we do, I think helps sort of keep that calmness that allows for the energy to have the passion for what we do.
And I'll just quickly add to that. So answer the phone, answer the chats, answer the emails, and deliver. That's my short answer.
Any other inspiration?
Well, I'm like Sharon. I aspire to inspire. You know, I try to coach, mentor, encourage, brainstorm with others when I think I have something to say that could help them better apply their talents, so that perhaps they can see a different perspective and contribute better in the work they do, or perhaps see a perspective of how valuable their time and talents are at meeting your goals. And generally, I try to keep a sense of humor and see that, you know, I don't know about you, but I really love what I do. I mean, in spite of the bone crushing workload, in spite of all of it, I love being able to provide information so that we can, information, data, knowledge, and make a difference in providing, you know, information to sustain and enhance the health, diversity, productivity, forest, you know, the nation's forest and grasslands to meet the needs of present and future generations. Anyway, I just try to help, I don't know, be a pick-me-up in the day, if that's, or at least not be a downer in the day of folks that I work with. Thank you.
Thank you. Okay, I'm going to bump to the last question. This is rapid fire. And in 30 seconds or less, because we do have a hard stop, what do you think is the best outcome for the FIA program? What would it be from advancing this science strategy? And, you know, if you want, how would the people listening to this discussion help us get there? And go. We have 2 minutes.
I'll go first, I guess, Sarah. Yeah, just building on the right science kind of thing. I kind of think of it as having the right people doing the right thing at the right time, right? And if we can put all those together, we should be able to, you know, increase our focus on where we're going, be more efficient and effective, and just get things done more quickly and meet our stakeholders' needs, you know, more effectively, I guess.
All right, thank you. Way to stay under 30 seconds too.
It might be cheating to say ditto, but ditto to what Jim just said, and emphasis on the stakeholders, meeting the stakeholders' needs. That's ultra theoretical. So that's all for me.
I'll jump in and say, I think if it's looking for a best outcome, I'll just say the shared understanding and buy-in from FIA employees and from station and WO leadership, so that we are all pulling in the same direction, all collaborating together towards successful outcomes. That would be really terrific and make our life so much easier. Thank you.
Yeah, I'd say ditto. To add on to Linda, Linda said almost exactly what I was thinking. I would add partners, that our partners are also bought into that, and our end users are bought in, and we have shared ideas of where we're headed and the priorities, so that we are indeed meeting their needs.
Thank you all so much for your thoughtful answers to these questions, your great presentations, and we made the hard stop. So you can continue this in the Whova app by contacting people there. You can also contact Natalie Renkes, the project manager, if you have more questions. Thank you all, and I hope you enjoy the rest of the symposium.